And as for point A, okay, this is the end point, which is back to 0. And I have it as this point O, which is at the origin. So this is, I stop there, then I'm going towards this end point. That means this should be my x naught, my x1, y1, and this is the end point, x2, y2. So if I apply that same formula, I have y minus y1 is 1 over x minus x1 is 0. Then y2, that's 0 minus y1 is 1, and x2 is 0 minus 0. So trivially, this becomes 0, and then x times minus 1, that's minus x. So I have 0 is equals to minus x. And when you cross multiply, you have 0, you have minus x. So here in this case, s is equals to 0. So the equation of this line here is that when x is equals to 0. That means whenever I see x here, just put 0. So trivially, the whole of this expression will cancel. Everything here becomes 0 because x, 0 times dx is 0, 0 times dy is 0. So everything here becomes 0. So the integral of 0 is still 0 because you have to bring out the 0 outside. So whatever you are integrating times 0 will surely give you 0. So do you understand that? So that's how it works. Then the next thing for us to do from here is to substitute this expression. Here I have y equals to 0. Put y equals to 0 here. Okay, and trivially, if y is equals to 0, if you differentiate, what's the y ds is also 0. This is gone. And then in this case, if you set y to be equals to 1 minus x, 1 minus x in this place, we need dy. And what is dy? Trivially, dy is equals to, like, that is saying dy dx. Okay, dy dx, you still cross multiply. So if I differentiate this thing, I will have 0 minus 1, and that's minus 1. Minus 1 what? Dx. So that means, take note, this dy will represent minus 1 dx, which is minus dx. So on substituting, I'll end up having this integral I'm actually working with to be equals to, I want to do for this part. For part OA, I have x squared, it's at when y is equals to 0. I have x squared dx minus, if this y is equals to 0, abi, for this part, then that means everything here becomes 0. So I have just x squared dx. Next thing is plus. So what's the next integral? I have part AB. It is at when y equals to 1 minus x. So when y is equals to 1 minus x, let's substitute. I'll have x squared dx, then minus 2x, y is 1 minus x, and also is multiplying dy, and dy is minus dx, according to what we have here. Okay, so, and then finally, for the part BO, remember that the part BO is at when x equals to 0. Put 0 here, I have 0, 0. Integral of 0, everything here becomes 0. So if you integrate 0, that should be 0 directly. And then I have the integral of 0 to e of s squared dx, plus ab, I have x squared dx minus, if this minus multiply this minus, I should have plus, and then I'll be left with just 2x minus 2x squared. Then finally with dx. Do you understand that? What I did was, minus times minus is plus, so I should have written this back by opening up the bracket. 2x times 1, that's 2x, and 2x times minus x is minus 2x squared. So I have dx left here. So what's the range for x? So I can just substitute it there. Since I have change in x left, so what's the change in x I have for this along this line OA? The change in x is from starting from 0, then it changes to 1. So that's from 0 to 1 of x squared dx. And for the part AB, what I have left is change in x also. Sorry, I have change in x. So let me just simplify. No matter how you do it, I'll still have change in x. So for part AB, change in x is starting from 1 to 0. So it changes from 1 to 0. So whatever I have left now, dx is common. So I should have x squared plus 2x, then minus 2x squared. Finally with dx. So next thing for us to do here is to, I want this integral, this lower limit and upper limit to look like this. So you know what to do. Just apply the property. And that property says that I should have negative minus when you swap it 0 to 1, right? Then I have x squared plus 2x minus 2x squared, then dx. Here in this case, What I notice now is that they both have the same limits. So I have 0 to 1. So and the x is common to the two term, that's x squared. Minus is multiplying everything I have here. So minus times x squared, that's minus x squared. Minus times 2x, that's minus 2x. Minus times this, that's plus 2x squared. Then dx. So whatever I have to do here, this will cancel this. So what I have left now is 0 to 1 of 2x squared minus 2x dx. Now if I integrate this, what will I have? Okay. So let's just solve it by hand or use a calculator, anyhow you want it. So if I integrate 2x squared, what will I have? I will have 2x cubed over 3. If I integrate 2x, that's 2x squared over 2. Remember, I will have to put this lower limit and the upper limit. And then this gives us 2x cubed over 3 minus this 2, we cancel this 2, I have just x left. So 0 to 1. So let's substitute when x is 1. For the upper limit, I will have, when x is 1, I have 2 over 3 minus 1. Do you agree with that? Then, what next? Minus, when I inside the lower limit, I have 0 minus 0, and that's 0. I'll put 0 here, that's 0. So what's 2 over 3 minus 1? And that should be 1 over 3 also. That's minus 1 over 3. Hence, the final answer for the evaluation, when you evaluate that integral, whatever you have left is just minus 1 over 3. This gives us the final answer to that question. Okay, so so far so good. I've explained the one of when you have just something like just a curve, like that one that we solved, that the question was y equals to 4x squared. And there's another one that we solved. I think that one was in this format, that's semi-cycle. And at the same time, this is the second one I did. The third example shows a whole cycle. The fourth one is when you now have what? This triangle. So the last example I'm giving is, what if you have rectangle? Just follow the same process. For rectangle, you just go towards this direction. Okay? Just follow the same process. Find integration of line from here to here, plus integrate it using this pattern. Then at the same time, add it to this, then like that. That's how it works. Okay? So if you understand the pattern, you should be able to solve any questions based on line integral. Okay? So that's how it works. Thank you.